what we are going to be learn on today's live session. Okay, so first of all, today we are going to be learn about the RTOS fundamentals. Okay, so this series. So in this one, so we are not only going to be study about data's fundamentals, so we are going to be see it from the fundamentals to advanced RTOS programming language. So before we need to be write a code and everything, we need to be understand the fundamentals of RTOS. Okay, so that's what this first live. So we are going to be discuss about all the fundamental things which is present in this RTOS. Okay, and we will study each and everything step by step. First of all, we need to know what is RTOS. Right. So its full form is real-time operating system. RTOS full form is real-time operating system. So that means RTOS is an operating system. So that we have been clear this point. So RTOS means it is one of the operating system. We already know what is operating system. So the operating system which is present in your laptop, we heard about the Windows, Linux, Ubuntu. So these are the operating system. So what is the function of operating system? It is one of the what can I say? So before we are going to be know about the real-time operating system, what is the function of operating system? So we already know this. It is going to be the helps to interact with your hardware. So how to store your data. Okay. So how to process the data and memory allocation. So everything it is going to be done in operating system. So if you just simply open the task manager and we already see this concept and it is helps to allocating the task. So the processor can helps to process that data. At the same time, it's not only helps to processing the data, it helps to storing the memory for each task. How many memory going to be allocated? Okay, how many network it does need, and the same for if you just look out the device manager and what are the external device has been connected with that, and if you just look out this file management, it helps to storing all the data. So these every function which is going to be done by your operating system, normal operating system, which is going to be helps to do all the functionality. Okay, but your real-time operating system, it's not like your operating system, normal operating system like Windows and Linux. Because this real-time operating system, this operating system is a special operating system. So the main thing is all the task has been completed on time without any delay. I hope you got this one. So if it is having any task in normal operating system, if you are giving any task, the number of tasks you have been given, but it can able to do, it can rush to do that task. But there is no time prediction, there is no deadline in it. Okay, but if you just look out this real-time operating system, it is a special operating system. All the tasks has been completed on the time without any delay. So that is the main thing you must be understand in the real-time operating system. Okay, in short, what we call it as in predictable time is guaranteed. So if there is a two comparison, so we are going to be definitely see this one. Okay, what is difference between operating system and RTOS? That means real-time operating system. Okay, so here also you can able to do the multiple tasks, can able to process. Here also you can able to do multiple tasks to be processed. But the thing is, it can able to rush to do that data going to be processed, rush to do complete the task, but not exactly within the deadline time. Okay, it can make some delay. Okay, but if you just look out this real-time operating system, there is no delay in it. It should complete with the specific deadline. So this is the main thing you are going to be understand RTOS. So when you are going to be deploy, when you are going to be build a product, that product should be work with that specific time. Work which should be complete its tasks, complete its task with a specific deadline. All you need is a real-time operating system going to be performing inside that. Okay, so you can use this operating system, but you can't expect the guaranteed time. So you can't expect the predictable timing. So the predictable timing means it should be complete the task within this 10 millisecond. You can't predict it on here because when you're going to be rushing the task, so more tasks to be completed, it can't able to complete within this 10 millisecond. But you can expect the thing which is on this real-time operating system. Okay. In short, timing is guaranteed. So in normal operating system, it just focusing on completing the task as much work as possible. It will be do. So if how much task you have been given that, it will try to complete as much task within that time, but you can expect some delay in it. But it is not. It is a guaranteed time will be given. So it always focus the operating system, the real-time operating system, which always focus on the correct timing. It should correcting. It should be complete the task within the specific timeline. This is the main difference between normal operating system and real-time operating system. And now we are going to be see that who needs it, who actually need this real-time operating system. So we can use this real-time operating system in multiple applications like embedded controller, automotive cars and vehicles, IoT device and destination. First of all, embedded controller. We can simply use in microcontroller. Like you can, if you just interfacing with sensor, okay, for example, you are having a microcontroller. That microcontroller should support RTOS, real-time operating system. Okay, so in this scenario, if it is supporting the RTOS, your microcontroller does supporting the RTOS. If you're just interfacing with any sensor, any motor, any actuator, the data collecting, we can expect the predictable data collecting. For example, you have been given like 10 millisecond, you are going to be, for every 10 millisecond, you are going to be collecting the data. So you can expect the good predicted value. Okay. So you can expect this one. Okay. So for every 10 millisecond, the data going to be given to them. Okay. So the ATAS, which is going to be helps to produce the data properly. So if you want to be collect the data within the 10 millisecond, you can able to collect all those data with this time, with this specific time. So if delay happens, it may happen some failures. In automotive cars, so we can use in automotive car, engine control. If you want to be control the engines, if you want to be control the braking system, if you want to control your airbags, everything you can able to deploy here. Okay. So if you want to, because we know that because this braking system, your airbag system, your engine control, these are very crucial because these are the things, these are the stuff which expects the deadline. That means if the brake which is not work with a 0.01 millisecond, the person will get damage. Okay, so you will got some so the disaster going to be happen. If there's an airbag going to be happen with this fraction of second, the inside the people will got damage. So the engine control going to be not working properly, it will be causes some disaster. So these are the place we can use this RTAS. Yes, we can use. So whenever we want to be maintain the specific time. Okay, so if you want to be do every task with that with does have specific time. So if you want to be do with that task with 10 millisecond, it should be completed within this 10 millisecond. Yes, you can implement this RTAS there. You can implement there. Okay, and in IoT devices, you can use this collecting the sensor data. Same thing, it happens in wireless communication. That means whenever you want to be collecting the data, okay, you want to be collect the data for every 10 millisecond continuously want to be collecting the data. So this scenario 10 millisecond you want to be at every 10 milliseconds you need to be connect the data. For example, you just consider one gas sensor. What you did is you just inserted in your home. So you know some hazard is going to be happen. You already predicted it. So previously you just inserted one gas sensor at your home. and you just connect your sensor. So you just, with the help of any microcontroller, you just connect with your mobile phone through Wi-Fi or any applications you're always checking. So you're just collecting the data first. Okay, you already predicted for 10 to 30 values, it is normal. If it is go above this 10 to 50, it's a hazardous value. Okay, just giving some notification, but you already given the data like at every millisecond, 10 millisecond, I need to collecting all the data continuously. So this time it is going to be helpful, okay, because it is following the deadlines. An industrial mission. So whenever we just motion controlled robotics and PLC, because creating a petroleum diesel, so people used to do this PLC, so they will controlling all the applications, almost be automative, okay, but need to be do the task with specific deadline. So they must be use this RTOS in their industrial applications. We can use it everywhere. So whenever we need, whenever we want to design on product, that product should be have this criteria, time constraint one. We can go with this application. We can go use this real-time operating system. So we can directly implement this real-time operating system. The main point you must be know about this one is our task is guaranteed one. Okay, you can able to predicting the timeline. Okay, the task must be completed with this time. But normal operating system, we can't predict the guaranteed time, because whenever we just dumping the task, it will try to complete as much as faster, but it is trying to complete it, not giving the guarantee, not give the assurance. So that is the difference between your normal operating system and your real-time operating system. So this is the common, what is operating real-time operating system. So real-time operating system is one of the operating system, like a software only. Okay. So it helps to communicating with the hardware, like, yes. So we saw the what are the hardware, what are where it actually going to be used. So whenever we want to design one product, at the time it should be, the product should be reacted, the product should be completed its task, everything should be as some deadline, should be completed with a guaranteed deadline time means. So you just directly go with this real-time operating system. Okay. And now we are going to discuss about the hard real-time and soft real-time. In real-time operating system, we are having a two types in it. One is called as in our task, we are having a two types. One is called as in hard real-time, and another one is called as in soft real-time. So what is meant by hard and what is meant by soft means in hard real-time. So we are going to be see the two difference. First of all, in hard real-time definition, we are going to be discuss hard real-time does having the should be have the maintain the deadline. Okay, the deadline must never be missed. Okay, so for example, you have been given the deadline of 10 millisecond means it should be completed within this 10 millisecond or less than this 10 millisecond. It shouldn't go above this 10 millisecond. If it is crossed the line, it will be causing a disaster. So the timing guarantee is very strict. If you have been given, already given, it should be open up. It should be done the task within this timeline. You should done the task within this time. The task must be finished exactly on time. Even 1 millisecond delay, it causes a failure, it causes a disaster. If you just see the examples, yes, the very good example is first of all airbag. We know that what is the purpose of airbag. So whenever we just traveling into the car, if any problem is going to be happen, if any trying to hit with any other vehicle, at a fraction of second, for example, you have been already assigned in the code, like, so whenever the car is hitting with any other vehicle or any object, the airbag should be open at 0.01 millisecond. This is the task has been allocated for the specific airbag. Okay. For example, the 1 millisecond, if it is open at 1 millisecond, it just open like this. Okay. If, for example, in another case, In another case, if the airbag is instead of opening in 0.01 millisecond, it is trying to open at 0.2 millisecond or 0.3 millisecond. So instead of opening it fully, so it will be open up to this. Okay. So at the time, so inside the person will definitely get damage. They will the disaster going to be happen inside them. So this very mild millisecond, this time duration, which causes a big disaster. This is called as an hard real time. Okay. So this is called as an hard real time. If you just look out the pacemaker, which helps to creating a pulses. So the heartbeat. So instead of there is no heartbeat persons, we are going to be inside the pacemaker. We just think about it. For millisecond, there is no heartbeat in there. It doesn't provide any pulses in it. So the person got damage. The person got feel the disaster. So the problem might be happens. There is no heartbeat means it is going to be creating some problem. Pacemaker means it will be helps to creating the pulses in it. It will be causes a disaster. Same for the braking system. So if you are driving any car, if you're driving any bike, so the brake should be happen whenever we just handling the brake, it should be reacted at the fraction of second, right? Within within the 0.01 millisecond. So they must be allocated some duration for that. If instead of reacting within 0.01 millisecond, just think about it, just reacting 1 second. When I'm pressing a brake in this place, the reactant, the response must be I get from this place. So this duration, it will be causes a disaster. So these are the problem going to be avoided. We just use the real-time operating system in it. In most of the cases, the time constrained area, we go with this real-time operating system. So these are the very good example for this hard real time. Okay, now we will look out the soft real time. Okay, and the design goals. So it should be guaranteed time. You are going to be deterministic scheduling. So we are going to be discuss about the deterministic scheduling. Okay, and it is having a guaranteed timing. Okay, so your time should be predictable, because if you're just using any airbag or braking or pulse pacemakers, so everything, whatever it could be, guys, you should be predicted. If it is, whenever it just using when I'm applying brake, you know that what is the response time. What is the response time? If I'm just applying a brake, what is the response time? Whether it is 0.01 millisecond, if you just the accident is happening, what is the opening time of airbag? It is a 0.03 millisecond. So you should be having this kind of predictable values. Okay, so that's all your hard real time. So hard real time means you just keep it on the mind. Deadline shouldn't miss. If it is happen, system will be failure. Okay, this is completely for hard real time. And soft real time means, so what does soft real time means? It The definition of soft real time means the deadline may be missed, may or may not be missed, but not always. Okay, if you just go to the soft real time, if you just go to the soft real time, like if I already explained about, if it is 0.03 millisecond means it should be reacted at the time or below for hard real time. If you just look out the soft real time, the timing, the small delay must not be creating big disaster. Okay, that is the definition. So if you just having you're just, for example, we are playing a games, okay, in our phone. So you felt like so some angst which is happening. So you're trying to put one attack which is not properly, you can't able to put at the specific time, some delay. So some delay was happened that time. So but that are the thing which is not going to be giving big disaster. Sometimes it just creating a quality of service. The quality of service has been reduced there. We easily predict, right? So this kind of stuffs is not actually creating a disaster. Because when I'm playing a game, if it is not worked at that specific time, the hang which is going to be happen, if it is lag going to be happen in your phone, this is not going to be creating disaster. You might only the quality of service. The quality must be reducing. So this soft real time is also every time if it is happening, it will be totally spoil the product. It might be happen, but not always. Okay, so the soft real time, the delay is going to be happen. It doesn't going to be creating the it is not going to be crashing your system, but your quality of service is going to be reduces. Okay, okay. So the quality of service is the main thing you're going to be understand on the soft real time. Example, for example, we are just watching a video. For example, some frame going to be dropped, some lags, some frames you got stuck in video, just got loading the video. So these are the stuff is not going to be happen. So the quality going to be suffer. So we might be missed some scenes at that. So when you're going to be a video call with your friends, so you might be saw this one. Okay, you might be felt like the sound clarity going to be dropped, but still, again and again it will be continuous. Okay, the playing a game, so you will lag. That will be reducing but the game doesn't going to be stopped. It is going to be happens. So a person is not going to be get any suffering. Okay, so the product quality only going to be suffered. The product quality of service only going to be reduced. The soft real time doesn't going to be affect any person, anyone, just affecting the quality of service. In hard real time, it is affecting the quality of the product. At the same time, it will be affecting the persons. So this is the difference between the hard real time and the soft real time. Okay, so you're going to be understand if you are going to be design the goals. There is no stick to timelines. It can going to be missing some deadlines. Okay, okay. So the soft real time deadline going to be missed, the quality of drop. So this is the key takeaway point. You are going to be keep it on the mind, guys. Soft real time deadline going to be missed, the quality going to be drop, but system still going to be works. Okay, so this is what the thing about this, guys. I hope you got. In short, we just look out this in hard real time. This is the thing. It is a do or die concept. Life or death. Hard real time will be causes. Soft real time, it is a user experience. It's just reducing the quality of services. Okay. I hope you got clear on this point. If you got everyone clear on this point, you just post clear on the chat box. Everyone can post clear on the chat box. Yes, Varnit Gupta, it is going to be used in rocket, in space mission, because whenever we want to be launch a rocket with this deadline, yes, we can use it because the missing that deadline, it creating the disaster. Okay, it's not going to be launch it properly. So I already silver membership. I want to gold membership also. So Pandi Rajan, so you're asking for this gold membership. So I'm going to be give the link for gold membership right now. So you can, if you want this enroll for this one, you can enroll it right now. I'm just give the link on the chat box. Once you have been enrolled, you just acknowledge me. Okay. So I've been given the link for this gold membership link. So if you want that, you can enroll it. So Heyman got clear and Bhargavi got clear and Saurabh and Aishwarya, Moin, crystal clear, Yokesh. So all the people have been posting got clear, clear, clear. Give me a minute, guys. Yes. So the next one we are going to be discuss about this determinism and latency. Okay. So what is mean by determinism and what is mean by latency? Okay. That's what we are going to be discuss right now. The determinism is called as an ability of ATAs to guarantee predictable behavior. I already told to explain about this. Okay. This thing is you can predict the value. Okay. In normal operating system, if you just simply go with this normal operating system, we don't know the exactly when the task going to be completed. The task, whenever the task has been given, it is continuously going to be do the task. Okay, it is continuously busy. It may be delaying your task going to be completed. In a real-time operating system, the task is fixed. It is the predictable timing. So if you're just giving a task, okay, if you're just giving a task and it is having some predictable time, it is going to be completed 0.03 millisecond. It will be completed within this time second, within this millisecond. So this is what we call it as a determinism. So guys, you just please keep this all point on your mind or note it down this point. Because first of all, we first understood the fundamental data and then we will go to write a code for this. Okay. So first of all, what is determinism? The determinism which is going to be you can get the guaranteed time. Guaranteed time. So that is called as a determinism because in normal operating system, we can't predict the exact timing in it. It can do the task whenever the user can uploading the task, it is continuously going to be do. There is no specific time should be completed. But in RTOS, the term it is called as determinism because we know that it is complete the task within this time, within this deadline time. Okay, so that is the determinism. Okay, example. So you just RTOS can guarantee that a motor control task execute every millisecond with the no jitter. So here you can understand it is having guarantee time. Same example you just take it. You just using sensor. Same example you just take it. Any gas sensor or any soil moisture sensor. Okay. You are just planting in your garden. Okay. So you're just using one soil moisture sensor. You insert the soil moisture sensor in it. And through IoT, you just collecting all the data. Okay, you have been insert on any microcontroller. You are collecting the data. So the data have been collected. So 100 to 500, the soil is dry. And 500 to 800 or 700, it is normal condition. And 800 to 1000, it is good moisture level. And 1000 to, that's what you have been written in your code. Okay, so this is how the data is actually going to become. Okay, so whenever it just giving a data like 400, 500, you're going to be easily predicted the moisture level is very less. There is no moisture level in it. So you can collecting those data. So you already given in a code for every 10 milliseconds, you should collecting the data. Okay, this is the task. So that is called as a deterministic. Okay, because you already know for every 10 millisecond, I am going to be collecting the data. This is how it is actually going to become. So in this case, here I've been mentioned one concept called no jitter. What is the meaning of jitter? It is the variation in the time delay. So between the data packet as well as the travel across the network. Inconsistency. For example, we will go with an example, in real-time example. Here I've been explained with one UART concept. Okay. Here, for example, you just take on soil moisture sensor, it's just having a UART communication. We already discussed about the UART protocol, right? So in this UART communication, TX and RX pin. This is your microcontroller, guys, and this is your mobile phone. This is your mobile phone, and this is your sensor. Okay, this is your this is your soil. Okay, you just insert the soil, your sensor, and it just continuously providing the data through your communication. Okay, in that you just already mentioned 10 millisecond is the deadline of the time. But what it actually doing is first data is coming at 9.5 millisecond, the duration. Okay, it just reaches at that time. Second data 10.1 millisecond. Third data 10.5 milliseconds. So the variation in the time, it is causing a delay because it is called as an continuous streaming of data you are just collecting here. Okay. So here, this case, it just variation in the continuation of data. It is not creating any new event. The continuation of data, you felt some delays in it. This is called as a jitter. This is called as a jitter. Okay. So whenever you want to be collecting the data, whatever it is, the variation in collecting of data, okay, the variation which is happening in collecting of data, this is called as a jitter. Okay, this is called as a jitter. Okay. So the next one we are going to be discuss about the latency. Okay, you can able to see this one. If, for example, another example, you just look out it. I've been connected your communication protocol. I need to be collected exactly every 1.0 microsecond at every or not for microsecond. I need to be collecting the data, the baud rate of 9600. Okay. In this scenario, in reality, one bit as came at 0.3, 103.8 microsecond. First data came at this time. Second data has came at 104.3 microsecond. The variation is happening. It's not deadline. It just came before the deadline. It is also not going to be tell it as a dead because the small variation only happened here. Right. But it is called as a jitter because these are the things it is called the continuation of data. It is not going to be happen at any time. It is not going to be happen as a new event. This is continuity of data streaming. So at the time, it is called as a jitter. Okay. And then the latency types. Before that, what is latency? So latency it's a time delay, guys. So don't confuse it. So it is called as a time delay. So the time delay going to be happen between the cause and the effect. That means when you ask the thing, okay. For example, this is you are having this is one of the example, guys. You just don't relate with this. You are everyone having a switch board, okay. So when you're going to be press the switch on your home, the fan or light which is turned on at the fraction of second, if it is reacting at 1 second later, this is called as a latency. Okay, because when the event has been occurred, when I press the switch, that is the event. When it was cast, okay, that is called as an event. When it was actually happened, when it was react, okay, it was react after 1 second. This is called as a latency. The delay when the event was occurred and it was reacted. That distance, that the time duration between these two, it is called as a latency. Okay, I hope you got clear. It is having a two types. Okay, the latency which is having a two types. First of all, we will discuss about the real time latency. Yeah, the same thing. When you're going to be press the switch, after 10 milliseconds, the light going to be turns on. The 100 millisecond is the latency. Okay. In computing, so when you're going to be trigger the sensor. Okay. So this example for we are going to be look out in the interrupt concept. Okay, I'm going to be explain it right now. In RTOS, your latency should be very, very less. Okay. Because that the example I told you, like whenever when I press the switch, the fan going to be turned on. After once again, That 1 second is a big latency, right? If it has happened in RTOS, it is the disaster. It is reducing the quality of services. So this kind of delay, this kind of latency is very, very low, and it is predictable latency. So because you can predict it already, it only 0.01 millisecond after it is going to be react. That is a latency. Okay. So this is the concept. Latency must be low and should be predictable values. And now we are going to be see the two main difference, two types of latency. One is interrupt latency and another one is a task switching latency. What is interrupt latency? So this is the example. So here I told you to explain this concept, right? So now I'm going to be explain this. So the time between hardware interrupts CPU starting ISR routine. Okay. So in this concept, we will go with an example. Okay. So you are having a processor. So you before going to be see the interrupt concept, guys, simply understand interrupt means your processor. Okay, just definitely your processor need. Processor is processing with any data. For example, just collecting a ADC data. I already collecting the data. In third one, so two person is speaking. The third person is trying to interrupt. It is called as an interrupt. Same thing is happening. Already the processor is interrupting with any ADC or any peripheral. Third concept, third peripheral is trying to interrupt. It is called as this one is called as an interrupt. Okay. So in this scenario, same thing. The processor is processing the data. Okay. This is called as an your gas sensor. Gas sensor. For example, processor is already processing the data. In third scenario, your temperature sensor is going inside that. Okay, it's just coming inside that. For example, you just look out this example. Temperature sensor detects overheating sensor interrupt to the CPU. Okay, so this example, so this one is going to be reacted. So gas sensor is already getting the data. I already getting the normal data. If the overheating of temperature sensor, it is producing some high value, it should be come and reacted at specific interval of time. Okay. For example, you are just using your laptop. Okay, this is one of the example, guys. So don't think about this real time. The example, you just open up, if you're just having a gaming laptop, for example, you are having a multiple application you have been opened. So whenever you're just opening the very big application, video editing kind of any gaming applications, so automatically the CPU fan going to be turned on. So this time, what it actually going to be happen? The processor is trying to be interact with any other software you have been opened, PPT or any Word, any the software you have been opened. It's going to be reacting normally. So whenever your processor, so whenever it felt very heat. Okay, so whenever it has felt very heat, just giving a indication. So at the time, it is going to be turn on the cooling fan. So it will be trying to cool the environment. Okay, so this thing, it is going to be reacted. It is going to be react, but it is going to be act as an interrupt. So the temperature sensor detected overheating sends the interrupt to the CPU. So the RTOS means the CPU respond. You can able to see it is 1 millisecond. The cooling fan going to be turned on. Okay. Okay. So if you just see the normal operating system and real-time operating system, if it is a normal operating system, the turning on the cooling fan, if you are opening up the many application, so when you are going to be trying to open up the heavy load of applications, giving an indication, your every component is getting heat. So turn on the CPU fan. So the reactant time will be 5 milliseconds to 50 milliseconds. But in our task, it should maintain the very low latency period. It is having just opening the 1 millisecond. The cooling fan going to be turned on very low milliseconds. Okay, that is called as an interrupt latency. Interrupt latency means, guys, whenever the two applications is already working, The third peripheral or third one is trying to interrupt and giving a priority to me and do the task I need. Okay. But the latency, you're going to be do one task, but you should take only the very less time delay. That is the interrupt latency. Okay. Interrupt is happening. The interrupt response should be very less. The interrupt latency should be less. The response should be high. Response should be high. The latency should be low. If you are having a less latency, only you can get the response, quick response. Other than that, it is not going to be response very fast. And then task switching latency. So what is meant by task switching latency means whenever you want to be switching the task. Okay, whenever you want to be switching the task, because CPU was always having the multiple tasks should be processed. It is not always the single task. You might be having the multiple tasks. This is the CPU. Okay. And you're just loaded with the multiple tasks. Okay. Processor. If you just look out any microcontroller, guys, in microcontroller data sheet, while you're going to be read out this data sheet, every peripheral does having the priority number. If you just take out the ADC, take out the UR, take out any I2C, any whatever it is, SPI, any timer. Okay. So each and everything which is having a priority number. If you just look out the data sheet and reference manual, it has been mentioned. So for example, the priority number is I2C is 1. SPI is 2, 3, 4, 5. Okay. Always you are going to be keep it on the mind. The less number is high priority. The big number is low priority. Okay. In this time, your CPU is processing with, for example, the processing with ADC. Okay. Suddenly, the timer is came. What it actually going to be do is, the priority number of ADC is only 4, but the timer is 3. So even though it just work with this ADC, it just stop the work and halt the thing and go to move with this timer because it is having the high priority number. This is called as a task switching contest. Okay. Latency, task switching latency. So this is commonly task switching, guys. But here how the latency is going to be happen. So the task switching means it already does the task with ADC, but the priority number of timer is high. It is switching the task. The switching time, it's just switching the task from ADC to timer. The switching time should be less. That is called as a latency switch. So the switching contents of latency is called as a switching the task from one task to another task. It is called as a task switching latency. Okay, so this is also should be very less. So here you can able to see that. So low priority task whenever it is currently running, for example, ADC, currently high priority task is coming. So what it actually going to be, the CPU shouldn't make any delay. Switching the task is very important. So in our task, CPU switching very quickly going to be happen. Okay, to the high priority task. So it just switching the task without any delay. It is not going to be taking high latency, very low latency. It is going to be switching the task. So it is going to be called as a time task switching. When it is having a two different type in latency, whenever already the processor is working, it is happen as an interrupt. Okay, interrupt. It is called as an interrupt latency. Whenever in here you can also taking one example. The interrupt of 3 interrupt is came right now. How it is how it is actually, which one it is going to be taking as a first, which one it is going to be giving the first priority by priority number. For example, already just working with ADC, same timer and UART I2C as came. The timer, first of all, just look out the priority number 4. It is not having priority number because it is having a less priority. And timer, it is having a 3, I2C 1 and SPI is 2. Okay, I2C 1, UART is I think 3 and this one is UART is 5 and timer is 3. Okay. Now it will be giving the priority to this one. So this is also task switching is happening. So only one task is come, it is called as an interrupt. Multiple things is come, it is called as a task switching. Switching the task from one task to another task. Okay. The time duration is called as a latency. Okay. And this is all about the thing. And finally, we are going to discuss about the RTOS architecture. What does mean by RTOS architecture? So yes, so what are the things which is actually inside this RTOS? Okay, first of all, the kernel, guys, because we already discussed about the kernel. What is kernel? Kernel is like your processor because you just take your microcontroller, any microcontroller, you just take it without the processor. The controller is nothing because we are customizing the controller because of this processor. We are taking any processor core and adding up the peripheral. We simply call it, it is a microcontroller. We should understand one thing. The processor specification is very, very important. Very, very important. If you are having a memory of the processor is 512 kilobytes, you can up to store that level. Okay. The processor should having a ADC. You can add up the ADC peripheral. If you are having a UART, so all the specification is done by your processor. So processing the task and managing the task, storing the data. So everything is done by your processor in controller. Same thing in operating system. The kernel is everything. Your kernel is everything. Okay. So if you just already discussed, if you just look over the task manager, so how the task has been allocated. So if you are having the multiple tasks, so for processor, how much the capability for each and every task it is processing, and how much memory in each and everything it need to be allocated. Okay, so memory it has been storing, so it is currently going to be changing, and how much network for each and every task it does require it. So this is processing data and how much capability, processing speed, and memory, and everything. How much network it has been required. Everything. If you just look out the device manager, so what are the device must be connected? What are the external hardware you have been connected at? So this thing and file manage. So you just have the assurance. It should be have the responsibility for everything. It should be process the data. It should be allocating the task. Okay, because if I'm opening any application, it should be allocating the into the processor. Okay, it should be allocating the memory space. It should be having some network. So all has been allocated in operating system. So at the same time, if I'm opening any file, so for all the management, file management, device management, your processing management, your task management, task allocations, everything. So he is the manager for your operating system. Your kernel is the operating, very important part. So what is it? The kernel is the core part of real-time operating system. Memory allocation, CPU allocation, task scheduling, memory allocation, timing, interrupt handling. So everything it is a very important parameter. The kernel ensure deterministic execution, meaning tasks run exactly at the expected time. We already studied about the deterministic execution. It should be completed with the expected time. What is the responsibility? So these are the responsibility, guys. So task management. If you want to be create one task, okay, if you want to be create one task, if you want to be delete one task, if you want to be suspect one task, if you want to be resume one task, okay, if inside that you want to be create one task, you need to be completed, you have been created it, okay, inside it is going to be allocated. If you don't want this, if you want to delete it, you can also delete it. If you want to be pass for some time, you can able to pass it. Okay, if you want to be do the thing like if you want to be resume it again, it is going to be help to resume it again. Okay. And interrupt latency. What is mean by interrupt latency is handle the hardware and ensure CPU response properly. So if it is any interrupt is going to be comes, CPU going to be responded properly. So it is going to be handle the interrupts also. Memory management. Okay, so it allocates the memory for RAM memory. So because all the processing data going to be stored the temporary data of RAM memory. Okay, that time it is going to be allocate the memory into your RAM. And timing on clock. So each and every task should have the timing, should be completed with this time. With the help of the timer, it should be already allocated thing. And what will be the delay? Okay, going to be happen. Periodic task means I already explained about if you want to be collecting the data continuously, like sensor data means at every 10 millisecond you want to be collecting the data. That is called as a periodic data. Periodic task. Okay. Okay. And example. Okay. Example means in airbag system, the deploy airbag system, the task must be run within 2 milliseconds. If it is not, it is going to be crashed. The kernel ensures the task executes exactly in 2 milliseconds with no delay. Okay. So with a no delay, it is going to be happening the functions. And task scheduler. Okay. So the kernel is the main thing is going to be that is going to be ensure it is going to be open at 2 milliseconds. Hence scheduler. What is mean by scheduler is he is deciding the which task going to be run next. Okay. Two types of scheduler. Okay. We are having a multiple task, guys. Okay. We are having a multiple task. In that multiple task, who's going to be run first, who's going to be run second kind of thing. Okay. We are having a multiple task. So who's going to be run first? Because we are having the 10 tasks in it or 8 tasks in it or 5 tasks. For example, I'm having a 5 to 6 tasks. Okay. So if it is a multiple task, who's going to be run first? High priority task going to be run first. How you are going to be find it out? Because of the priority number. So that one we call it as a preemptive task scheduling. Okay. Preemptive scheduling. So whenever you're trying to give high priority to the high priority task, that is called as a preemptive task. We know that if you are designing, if you want to be implement the RTOS in your car, okay, if you are just trying to implement the RTOS in your car, so you should be having multiple things like, so airbag should be open at 2 milliseconds. Braking system should be open within this, should be reacted with this time. So engine control, and if you are having a music player and multiple sensor, you have been connected with that, and okay, so these are the stuff has been connected over there. And if already music has been played, okay, so for example, it should be having which one is having high priority. So whenever the car is trying to be hit, instead of playing a music, it should be having a high priority to opening up the airbags. It does automatically get open at the 2 millisecond. So it just automatically get prioritizing the task. That is called as a preemptive scheduling. Preemptive scheduling. Okay. Cooperative scheduling. What is meant by cooperative scheduling means it automatically does the priority. I mean, does the project task. Okay. That means the task is automatically going to be done. So if you are having the multiple tasks going to be performed, if you are having a multiple task going to be performed, so automatically when the first task has been completed, switch to the another task. Switch to the another. If there is no interrupt has been came, if it is there is no preemptive job, work has been came, then normally it just do the cooperative task. Cooperative means it just synchronize. Like when the first task has been completed, just go to the second, third, fourth, fifth, sixth, like that. Okay, this is comes under the cooperative task. And a common algorithm is, so these are the algorithm we are going to be implemented in this RTOS, guys. So these are the very, very important thing. So main differentiate between your RTOS, main differentiate between your operating systems and your this real-time operating system. Priority-based scheduling. So priority-based scheduling is prioritizing your first, second job. Okay. So same thing, we call it as a preemptive task, right? This is called as a priority scheduling also. So whenever I task, so high number of tasks. For example, you are having a high priority task is coming, you should stop the low priority task and give priority to the high priority task. That is one. And round robin technique. What is meant by round robin technique is each and every task defaultly having some specific deadline. Okay. First one, you have been given the hairbag should be open at 10 milliseconds. It is going to be completed the task within this duration. And this braking system should be open this duration. It should be done with this duration. It's going to be slicing your time. For every time should be completed the task within this duration. So going to be slicing your timing. That is called as a round robin technique. Okay. And rate monotonic scheduling means whenever shorter time. For example, you are having a multiple task. That specific task going to be complete only within shorter time means it will be trying to complete the task first. So whenever it is having a very shorter period, it will be trying to complete that task first. That is called as a rate monotonic scheduling. And then earliest deadline first. That means whenever your task does having a very less deadline. Right, okay, it's just having a very less deadline. It does complete the task within this duration. You can go to do the task first. It is going to complete the task first. Okay. So for example, it does having a 10 millisecond, but it does having to complete a 5 millisecond means instead of complete this, try to complete this first and then go to this one. Okay, this is called as an earliest deadline first. So you won't think about it. Always the cooperative scheduling is going to be happening. It will be do all the scenario, all the algorithm. So you must be configuring which one going to be do here. Okay, whether it's just giving a priority to the shortest win. Okay, whether it is going to be giving a priority to the shortest deadline, whether it's just giving a priority to the shortest duration, it is going to be complete the task, whether it's just giving a priority to the high priority number. So these all comes under the algorithm. Okay, so you're going to be implemented. Which one going to be happen? Then the system services. So system services is RTOS provide the essential services like if you want to be creating is task, create, delete, suspend, and resume the task. These are the things you're going to be do. And in that, you're going to be managing the times also. How much duration and what the delay is predictable and periodic execution. Okay. So intercommunication. So these are the stuff we are going to be see it on tomorrow, guys, because task scheduling and all the stuff we are going to be discuss on tomorrow. Okay. So what is message queue? So all the tasks, it just arrange it as a queue first. And then it just take it one another task and implement the task. So semaphore means it is going to be synchronize your task. Okay. And these stuff you're going to be discussed on tomorrow. System services. Inside that complete task-based concept, you're going to be see it on next video. Okay. And hardware abstraction layer. What is mean by hardware abstraction layer is you want to be so same RTOS when are going to be implemented in your different microcontroller because we mostly use embedded system. We want to be created the embedded system. We implemented the RTOS, the real-time operating system most probably used in your embedded applications only, right? So in this time, we can use the same kind of RTOS in your multiple microcontrollers like ARM Cortex and PIC. So same kind of products we can implement at this one. That is called as hardware abstraction layer. Okay, provides the it directly interface with your hardware. Okay, so this is the common RTOS architecture. Okay, so this is what we have been discussed up to it. Okay, so I hope you got clear on this point, guys. What is RTOS? And what is the difference between hard real-time and soft real-time? What does it mean by determinism and latency? And what is mean by what is RTOS architecture? So everything we have been discussed.